Another way to find domain is using a symbolic representation. So basically using a formula or an equation. Okay, here for part A, we have f of x equals 3x minus 7. Now one thing that we could always do is we could always graph any function and find our domain and range graphically. But sometimes that's a little cumbersome. Sometimes, people don't like graphing so much. So it's really good to understand the domain in relationship to the equation. So here, if we look at 3x minus 7, the function that we have, we want to think to ourselves, can we plug in anything that we want for x and get an answer as an output? I like to always use, excuse me, positive values, negative values, and 0. Okay. Now another way that we can look at this is, are there any limitations to what we are allowed to plug in for x? So it's either what can we plug in for x, or are there any limitations? So when I look at this, I say, okay, well, can I plug in positive values? Can I plug in 3 and get an answer out? Well, 3 times 3 is 9. 9 minus 7 is 2. So I can plug in 3. Can I plug in a really, really, really large number? Let's say 1,000. So that's 1,000 times 3, 3,000 minus 7, which is 2,993 or something. So it gives us an output. Then can we plug in negative numbers? And I'll just use something like negative 5. Negative 5 times 3 is negative 15. Negative 15 minus 7 is negative 22. So I can plug in negative numbers. And can we plug in 0? 3 times 0 is 0. 0 minus 7 is negative 7. So we can plug in positive values, negative values, and 0. Is there anything here, any value that we plug in that will not allow us to get an output? In this case, no. This is a linear function. A linear function has a domain that normally is what's called all real numbers, from negative infinity to positive infinity. So the domain here, everything, we can plug in anything we want. So we can either say all real numbers. We can use the symbol for that, and the symbol is like this fancy R. Or we can use something called interval notation, which I'm going to discuss more at length later. But your interval notation for all real numbers is basically telling you your lower boundary negative infinity to your higher boundary positive infinity. So that would be negative infinity to positive infinity. And the infinity signs are like sideways 8s. Okay. Now what if we had a different function? What if we had a function f of x equals x over x plus 2. So here we just we just worked with rational expressions like this, a fraction, and we had one limitation for plugging in for, not x, but we had one limitation for this, and that dealt with our denominator. And we know that our denominator cannot equal 0. That's the limitation. So the denominator cannot equal 0. So you could, because this is really basic, you could probably think of, okay, well, what x value will give us a denominator of 0? And you could think about that and say, oh, okay, negative 2. Another way to do it is also to just take it and say, okay, well, x plus 2 cannot equal 0. And knowing this equation, that the denominator cannot equal 0, helps you, because what if this was a lot more complex? You'd have to think a lot longer. It might take more process of elimination. So it's good to know the basics of it, right? X plus 2 cannot equal 0. We would go ahead and subtract 2 from both sides. Say x cannot equal negative 2. So are there any other limitations? Can we plug in other negative numbers? Negative 5, negative 1, negative 57. Can we plug in positive numbers? 100, 2,000, yes. Can we plug in 0 for x? Yes, we can. It'll give us 0 on the numerator, so that gives us a whole thing of 0. So in this case, our domain, we can say it either as all real numbers, whoa, I can't write today, except negative 2. Later on, we're going to learn how to write this using our interval notation, which says everything below -2, but not including it, and everything above -2. I'm going to talk more about the interval notation later. Now, another kind of function that we can deal with is a radical function. So here I have g of x equals x minus 1. So we want to think of this as, okay, well, what do we know? What are our limitations, or what are we allowed to plug in? I look at this square root function and I say, what are my limitations? And I know that what's underneath the square root, which is called the radicand, I can't spell, radicand, there we go, that's nothing. The radicand has to be positive or 0, which means it has to be greater than or equal to 0. So now again, this is something that we could just think about and figure out, okay, well, what is going to work here? But it's also good when we have something more complex underneath here to know how to solve it using an equation. So here it would be x minus 1 is greater than or equal to 0. In order to solve inequalities, we just solve it like it's a regular equation most of the time. X is greater than or equal to 1. And we can double check that. Can we actually plug in 1? 1 minus 1 is 0. The square root of 0 is 0. So yes, we can. So here, we could say for our domain, let's move that up. We could say all real numbers greater than or equal to 1. We could also say that using an inequality, which is right there, right? X is greater than or equal to 1. And we could use that, so that's one way, that's another way. We could use interval notation, which again we're going to talk about in just a minute, as from 1 to infinity. Okay, so that's our symbolic representation, finding domain.